Hi, today we're going to be learning how to calculate the number of particles or the pressure when one of those variables changes. So we're going to write a formula for that and then go learn how to rearrange it, and then we're also going to look at the particle pictures, and then we'll do some actual calculations. Okay, so today's notes are called Unit 3, Topic Pressure versus Number of Particles. Okay. And we can see from the graph that this is a direct relationship. So as we increase the number of particles, we also increase the pressure. Okay? The formula for this is P1 over N1, or Pi over Ni, I'll say it that way instead, is equal to Pf over Nf. So Pi is the initial pressure, Ni is the initial number of particles, Pf is the final pressure, and Nf is the final number of particles. Now, if we want to rearrange these formulas, okay, and we want to, if we want to solve for the final pressure, say we know the initial pressure, initial number of particles, and final number of particles, and we're going to solve for Pf, then we're going to have to rearrange to get Nf out of this side of the equal sign. So we want Pf all by itself, and to do that, since Pf is being divided by Nf, to get rid of it, we'll multiply by Nf. And what we do to one side, we also do to the other side. So our formula for Pf equals Nf times Pi divided by Ni. Okay, so be careful copying those to get the right letters. So Nf times Pi divided by Ni. Now, what if we wanted to solve for Nf? That's on the bottom of the fraction sign. So I don't know if your math teachers taught you this, but one way to make it easier to do this is to just flip both sides. So if we flip both sides, we can keep the ratio the same. So Ni, I'm going to flip over here first. Ni over Pi is equal to Nf over Pf. So I just took the original formula and flipped it over. And that puts Nf on the top of the fraction line for me, which makes it easier for me to go ahead and get it all by itself, to isolate it, right? So it's on the same side as this Pf, and there, that's being divided. So in order to get rid of Pf, I do the opposite, and I multiply. And what I do to one side, I also do to the other side. On this side, it cancels, and on this side, it stays there. So we now have Nf, let's write that, Nf is equal, so final number of particles is equal to Pf times Ni divided by Pi. And just as a note, in case you forget, let's write it down. I stands for initial, and F stands for final. Now, in this formula, we don't see anything about volume or temperature, so those two things must be staying constant. So we just don't even have to pay attention to them because they're not changing. All right, and then we can write our conclusion statement. And our conclusion statement is, as number of particles increases, pressure also increases. And we have to think about why. So we'll say because there are more particles to collide with the container. Because remember, pressure is particles colliding with the container. Okay. So let's go ahead and we'll draw our particle pictures. We can see that number of particles is lowest at point A. So at point A on the graph, we have the fewest number of particles. Let's draw our box first. Our volume doesn't change, so I'm going to keep my box the same for A, B, and C, or supposedly the same, right? As close to the same as I can make my pictures. Just drawing with freehand. Okay, so N is getting bigger from A to B to C. So it's the fewest number of particles in A. So let's start with 3. And then at B, there's more particles, so let's go up to 4. And at C, there's even more, so let's go up to 5. Okay. Temperature doesn't change, so I'm going to give everybody one whooshy. Okay. Now, as I add more particles, there are more particles available to collide into the walls. So if I start off with one pressure, so if I have low particles, I have low pressure. When I add more particles, I might have more particles colliding off the walls. So I might have two. So medium particles, a number of particles really, but I'm just abbreviating it here, would be a medium amount of pressure. And then finally, when I have the most particles, I'm going to have the most amount of pressure. So let's have, why don't we have 3 particles colliding with the walls now? 1, 2, 3. So high number of particles gives us high pressure. All right. Okay, so go ahead and finish drawing all those pictures in, and when you're done, flip this over. You can pause the video if you need to finish. All right, here we go. Okay, now that we have those examples done, we're going to go ahead and do some problems together. We have 3 problems on the back here to work on. And as always, we're going to read through the word problem, we're going to underline the numbers, and we're going to circle what we're being asked to figure out. So, a soccer ball has an initial, let's first talk about units as I see this. Remember, if we have the units mmHg, that's a unit for pressure. And if we have the unit of puffs, that's a unit for number of particles. And remember, our abbreviation for that is just N, and our abbreviation for pressure is just a capital P. Okay, so now let's read the problem with that in hand here. A soccer ball has an initial pressure of 300 millimeters of mercury, and it contains 25 puffs of air. How many, so here's my question, puffs, so I'm circling puffs of air, should be in the ball to reach a pressure of 408 millimeters of mercury? Volume stays constant. So let me make the list of things I need to know. PI, we had VI, NI, then P final, V final, and N final. So my initial pressure, right here, it says my initial pressure equals 300 millimeters of mercury, and it contains 25 puffs. Remember, puffs represents my number of particles, so that's my N. So my initial number of particles is 25 puffs. And then it says how many puffs, so that's what it's going to be, right? So that's my question mark. I don't know how many puffs we're going to need at the end. And so should the ball be in order to reach a pressure of 408 millimeters of mercury? So again, millimeters of mercury is pressure. We have an initial pressure. This is our final pressure. So that would be 408 millimeters of mercury. And the question says volume stays constant, so we don't need that. We'll just put an X there, okay? All right, so my formula should have pressure and number of particles in it, okay? No V. It doesn't need V in it. I'm going to cross those out entirely. So it's not just that they're equal to X. They're just, we don't care about them. Okay, so let me see. I am solving for NF. So I want to use this formula. So NF equals. If I wanted to solve for PF, I would use this formula. PF equals all of that. So I'm going to use NF equals. And I'm going to make sure to copy it over correctly. So NF, let's write that first. NF equals, and let's be careful, PF times NI. All right, let's write that down. PF times NI, and then divided by PI. So it's PF times NI divided by PI. PI goes on the bottom. Okay, so now we know that. We've got our setup, and we've got all of our information written down here for us. So we're going to go ahead and take our numbers and put them into the formula. So P final So be careful so you put them in the right place. P final is 408 millimeters of mercury times N initial, that's 25 puffs, divided by P initial, which was 300 millimeters of mercury. Okay, so we've got, let me get my calculator out. We take our 408. Not sure if you can see it. There we go. I'll turn it so you can see it a little bit. Times 25 divided by 300. And that equals 34. And let me see what my units are. So I've got millimeters of mercury over millimeters of mercury, so that cancels. So it should be puffs. We're left with units of puffs, which is the unit that we want to use for when we're talking about N. N is number of particles, and we measure it in puffs. So that would be correct. All right, let's take a look at problem number 2. So in problem number 2, we have a glass jar that contains 5 puffs of helium gas with a pressure of 550 millimeters of mercury. A student uses a helium tank to add 30 more puffs of helium gas. What is the new pressure? Okay, that's what I'm circling. And then also volume stays constant. All right, so let me make a list of things that I know and things I need to know. We've got PI, VI, and NI. And then we've got PF, VF, and NF. All right, let's look to see what we know. So a glass jar contains 5 puffs. Remember, puffs is number of particles, so that's my N. So I'm going to write that here next to the initial, because it's like talking about it at the beginning, right? And then with a pressure of 550 millimeters of mercury. So this tells us that. That's our pressure. We also know anytime we see millimeters of mercury, we're talking about pressure. So that's going to be my initial pressure, because that's what it's starting out at. A student uses, okay, so then we see they add 30 more puffs, so that's going to be at the end, right, because they had to add it. It wasn't like that at the beginning, it's like that at the end. So that's my final number of particles, because puffs tells me about number of particles, right, looking up here. And so if we added 30 more, now let's be careful here. We don't have 30 because we added 30 more. We started with 5, right? We started with 5 and we added 30. So we have 35 puffs here. So be careful with that, because this problem is a little bit more, you have to read into it a little bit more. It's not 30 at the end, it's 30 more than the 5 that we started with. Okay? All right, and then what is the new pressure? So that means we're trying to find out the final pressure. That's our question mark. Volume stays constant, so we just cross it off. We don't need it. All right, we have PI, we have NI. We don't know PF, but we do know NF. So this time we're solving for PF. Let's go ahead and flip our paper over and look at our formula. PF equals NF times PI. Let's write that down. PF equals NF times PI divided by NI. Okay, so we get all the parts of it. So PF equals NF times PI divided by NI. All right, now we can take our information that we have over here, listed over here. The first thing we want is NF, so that's the final number of particles. And remember, that was 35, so it was the total with including what was added. So 35 puffs times PI, so initial pressure, 550 millimeters of mercury, divided by NI, so the initial number of puffs, and that's 5 puffs. All right, so we have all of our numbers. We're ready to use our calculator. So we have 35 puffs times 550 millimeters of mercury divided by the 5 puffs, and that gives me 3,850. Okay, and remember we're solving for final pressure, so let's see what our units are. We have puffs over puffs, so that means they cancel out, and we're left with millimeters of mercury, which is good because that is the unit we use when we're solving for pressure, when we're talking about pressure, and so we know we did our setup correctly when we end up with the right units, or that helps us to know. All right, one more problem that we'll do together. It says a student holds a syringe that contains 15 puffs. So again, anytime I see a number, I'm going to underline it with whatever units go with it and whatever important information goes with it. So it has 15 puffs of air particles, and it has a volume of 160 milliliters. The pressure is 672 millimeters of mercury. Let me go back and underline pressure. The student accidentally opens the syringe and then quickly closes it. The syringe now contains 10 puffs of air. What is the new pressure? And then they must have put it back to 160 because volume stays constant. Okay, so here, let's make our list of stuff we need to know, or that we could know. So I've got PI, VI, NI, PF, VF, NF. All right, so the first thing I see is 15 puffs, and so again, just checking out here, puffs is the number of particles, which is our letter N, so 15 puffs. All right, and then we have a volume of 160 milliliters, and a pressure, an initial pressure of 672 millimeters of mercury. Okay, then we see that it now contains 10 puffs, so this is later on. It contains 10 puffs. That's our N final. Oh. And it's asking what the new pressure is. So that'd be our final pressure is what we're trying to figure out. And then it says volume stays constant, so that's 160 milliliters still. But guess what? If it's constant, we don't care. We can just cross it out. We're not going to use that in our math. All right, so just so you know, if it's constant, just cross it off. We don't need it. Okay, this time we're solving for final pressure. And so the first time we solved for final number of particles, the second time we solved for final pressure, we're going to do that again. So let's use this setup of the formula. PF equals NF times PI divided by NI. Okay, and we're going to go ahead and plug in our numbers. Final number of particles is 10 puffs. Okay, and then that's going to be multiplied by the initial pressure, which is 672 millimeters of mercury. And then divided by the initial number of puffs, or of particles. So Ni is 15 puffs. Okay, and if we take a look here, so now we have 10 times 672 divided by 15 equals 448. 448, and then our units, puffs cancels out. So our units are millimeters of mercury, which again is a good unit for final pressure. All right, after this you're going to work on the worksheet 5 and get that done today. Whatever you don't finish today is due for homework.